Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, and today we're talking about space and space travel and how it may become a little easier. So this is kind of a cool story. Maybe not for
Tiny,
my lifetime, maybe not for
yeah,
my lifetime, but probably for my grandkids' lifetime. This would be cool.
hopefully, yeah.
Yeah.
Tiny spacecraft riding beams of light could put humanity within reach of another star system in a single lifetime. So I'm thinking of like surfing light waves. That's what I'm thinking. That's what pops into my mind. The recent confirmation of an atmosphere around a rocky exoplanet called LHS 1140b has created a wave of interest within the astronomy community. The planet orbits within the habitable zone around its parent star, a red dwarf located some 48 light years from Earth. Would you like to know more?
Okay. So 48 light years, that's going to be more than a weekend jaunt, right? To get there.
48 years at the speed of light, so we'd have to go faster than light to get there in someone's lifetime.
Yeah. Okay. The habitable zone is the region around the star where temperatures are just right for water to remain liquid at a planet's surface. Uh, Astronomers detected helium being lost from the upper atmosphere of LHS 1140b, but heavier chemical compounds such as water, which is a key ingredient for life, could exist lower in its atmosphere. So yeah, water we need water, right, for
Yeah,
all kinds of stuff. So
well, oxygen too. Yeah.
yeah.
So, observing distant exoplanets using telescopes opens new doors for science. We've reported on this many times, Scott. But will it ever be possible to travel to these worlds and observe them up close? While this has generally been seen as the stuff of science fiction until now, emerging technologies allow us to imagine a future where such missions are possible in the decades ahead.
There is particular interest in miniaturized spacecraft for interstellar voyages. In large part, this has become it's easier and cheaper to propel a small spacecraft to another star system and have it get there within a person's lifetime than it is to do the same with a large vehicle.
Miniaturization of sensors has seen great advances, for example, through smartphone technology, where highly capable cameras with low mass, power, and volume are routinely used. Researchers have seen developed smart dust sensors that are millimeter scale in size or smaller that can detect light, temperature, or chemicals.
The space probe itself would need a form of propulsion capable of accelerating to a mildly re- relativistic speed.
Relativistic.
What is it? Relativistic?
Yep.
Relativistic speeds, say 10 to 20% of the speed of light. After a travel time of many decades, the sensors would pass through a target star system without stopping, making it in situ observations and then very slowly dripping data back to Earth. So we're talking like, oh, here we go. You're going to talk about it. Okay.
Yeah, so 10% of the speed of light going to that planet 48 light years away would take 480 years.
That'd be
So
tough.
that's generational.
Yeah.
Okay, like great, 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 great grandchildren. All right, this isn't quite Star Trek, but it's a potentially plausible idea that would enable us to study neighboring stars and their planets up close. This kind of concept has been actively pursued by a philanthropically funded venture known as Breakthrough Starshot. This program investigated the key technologies required for an interstellar journey using small probes.
Light sails are seen as one of the most suitable forms of propulsion for such a mission. As the name implies, these are thin, reflective membranes. For for interstellar travel, directed energy from a laser could be used to push the spacecraft forward. Photons, the quantum packets of energy of which light is composed, transport momentum as well as energy. Therefore, when light reflects off a mirror, it exerts a pressure on the mirror.
In most circumstances, the pressure due to light is imperceptibly small. However, for an intense enough beam of light in an ultra lightweight membrane mirror, light pressure can act as a means of spacecraft propulsion. In order to accelerate a light sail to relativistic speeds, a hefty laser would be required with an effective power of tens of gigawatts. This would be a single, well, let's use a flux capacitor.
Well,
This wouldn't be
you're definitely not going to do this from California, so
right.
we can't even charge cars. So
This wouldn't be a single device. Instead, it would probably comprise an array of separate laser devices synchronized together to generate a beam of coherent light. And if those get out of sync, forget it, man.
you're lost in space, huh?
Hmm.
Pushing a reflective light sail a few meters across with such a laser would accelerate the sail to its cruising speed in a matter of minutes. The advantage of beam power propulsion systems seems is that the laser assembly is left behind and only a small payload is accelerated to the stars. In contrast, conventional rockets have to haul their own propellant, which puts them at a severe disadvantage for such ultra high energy missions. Yeah, I don't know. Well, they were talking, got to have a small craft versus a large craft. So,
If they're saying that the laser assembly is left behind, so it gives that burst and then it drops the laser, this is a one-way trip because it doesn't have a laser to get back.
right.
Yeah. And I'm of the opinion, you know, how Voyager has been so successful at traveling and taking photos and communicating back. We should launch 10,000 probes to 10,000 different stars. And then in 10, 20, 30, 50 years later, it starts sending information back and we'll have it. Right now, we don't.
Well, that's all the Voyager, right? In fact, I was reading about something about that the other day that they expected this mission to last maybe a few years, not decades. And it's been an amazing. They've definitely got their money's worth out of that Voyager mission. So,
If you want to find a habitable planet, start sending the probes out right now.
yeah,
Okay. The disadvantage, I'm off of my soapbox now. The
sorry.
disadvantage of beam power propulsion is that the payload cannot easily stop. So a probe would pass through its target star system in only a few days, while multi-gigawatt laser pushed light sails may seem to be a bit of a stretch at present due to the colossal scale of such a venture. Advances in miniaturization could pave the way for tiny intelligence sensor nodes to be our first interstellar voyagers.
Perhaps we'll first travel to the stars with an AI asleep at the wheel for decades until it awakens for a few days of frantic activity as our machine proxies get their first glimpse of alien worlds.
Aside from pushing light sails with gigawatt lasers, reflective membranes can also be pushed by light pressure from the sun. These solar sails have a long and rich history and were first proposed in the 1920s by Konstantin Tsiolkovsky and Frederick Sander, two of the great Russian pioneers of astronautics. Tsiolkovsky wrote of using, quote, tremendous mirrors of very thin sheets.
While laser propelled sails are for the future, solar sails are for the present. A number of small solar sails have already been launched into Earth orbit for technology demonstration purposes. Scaling up solar sails for deep space missions could deliver a new set of tools for exploring our solar system.
First, since solar sails do not need to carry propellant, they are capable of high energy, long duration missions, some of which are just about impossible for conventional spacecraft. For example, rendezvousing with a long period comet on an elliptical or highly inclined orbit about the sun requires significant energy.
Moreover, returning a surface sample from such a comet to Earth becomes even more difficult. For conventional rocket propulsion, the spacecraft needs to haul propellant for the return journey all the way to get to the target planet or target comet. That's what you were talking about earlier, I think.
Yeah. For solar sails, returning to Earth is little different from reaching the comet to the first place. Solar sails can tack by tilting the sail to gain momentum and so spiral away from the sun, or flipping the sail to lose momentum and spiral back inwards towards the sun, just like sailing.
Yeah, solar sails can also move along unconventional orbits, like with light pressure used to offset gravity. For example, this could allow a solar sail to hover stationary high above the poles of the Earth. Huh.
Solar sails and light sails are stepping stones from the present to the future and from exploring our own solar system to exploring distant stars. Perhaps exoplanet LHS 1140b will be visited by a light sail at some point in our future.
Okay.
How about this? We get the
Very cool.
AI to take embryos, like 1,000 embryos with it, wherever. And then once it finds a habitable thing, the AI wakes up, does its thing, and then starts allowing the embryos to grow into children. And I don't know, it's a radical idea.
Well, who's gonna? Yeah, you gotta have somebody there to teach them, right?
The AI.
Oh, AI is gonna teach them.
On the screens, yeah. They'll just
Okay.
make them look at the screens to learn.
Okay.
AI. Or
Wow.
she.
You're way over my head. Okay. Well, there you have it, folks.
You heard it first on Backyard Musings.
Yeah.
All right. Thanks a lot, folks. We'll see you in the afternoon.
See you this afternoon. Thanks.